So what do you think about this? What do I have to do immediately before I get the chart going? Yes. Good. Then? No, we are not done yet. But we will determine. If you want to jump to the degree, that's fine, but I still have to come back there. What is a degree? Good. How many maximum number of turns? 4 max turns. How many solutions? Yes?
So I don't understand the degree part. Is it different for odd than it is for even?
No. The degree of a polynomial is determined the same way.
So why would the other one do we add?
Because it was a product. You have to multiply x to the third by x squared and by x. You have to expand it to determine the degree. It's in a factor form. This is x cubed. When you square this, you get x squared, blah, blah, blah. And when this is x, right? So you have to distribute x cubed to x squared and to x. So x cubed times x squared times x is degree 6.
Okay, so when we factor this, we'll be able to just add it like we did with that one?
But you don't have to anymore. We already established the degree. I'm not going back to establish the degree after I factor it.
Yeah.
It's already here. It's clear. It's 5.
No, when we did the
Yes?
word problem.
Yes?
So there was 4 degree when there was 3 turning points.
Right.
Don't you subtract 1?
You go backwards. If the degree is 4, minus 1, 3 maximum number of turns. If you have the maximum number of turns, you go backwards to determine the degree. Better? Perfect. Other questions here? Very good questions. Other questions? Okay. So maximum 4 maximum possible number of turns. And how many solutions will I get when I solve the equation? 5 solutions indeed. Don't forget. Perfect. So I'm coming back. What else do I have to perform here? There is more to work here. And I'm not here and I'm not finished with that. Yes, domain. Okay, let's put the domain in. Okay, let's also put the end behavior. Since it's an odd degree, what is the end behavior? What is the leading coefficient?
Negative.
The leading coefficient is negative and the degree is odd. So what does that mean? What is the end behavior? So if its leading coefficient is this, it's positive, and then a negative leading coefficient is this, it's negative. Always think in terms of the linear function. If it's odd degree, linear function. So it's positive to negative. Do we agree? Please say you don't agree and I'll explain. It's okay.
Please explain.
Okay. So do we see the negative leading coefficient? How do I graph a linear function with a negative leading coefficient? Do I graph it like this, or do I graph it like this? If it has a negative slope. A linear
negative slope.
Yeah, a linear leading coefficient or slope for the linear function is the same thing. So that's why it's the same, because it's compared, this is compared to the linear function. So any odd degree is compared to the linear function. Any even degree to the x squared. Is that better? Perfect. So I still come back here. What do I need to do next? Yes, what? What else? Negative x, very good. What is left in parentheses? Awesome. Oops. X to the 4th. Yes. Minus 6x squared. Very good. Now we have to extensively work on this before I even do anything. And we know how, because we have the preparation from chapter 2. X to the 4th minus 6x squared plus 9. What do we do with this? And there is something specific that we did in chapter 2. Exactly. It's quadratic in form. Awesome. Thank you, Eric. Thank you. So I'll let y be. Very good. Awesome. So then this becomes, yes. You mean y squared? Yes. Very good. Y plus 9. Very good. Now what is this? That's why we did this on the first day of classes, because we see it all the time, all the time. How do I factor y squared minus 6y plus 9?
Y minus 3.
Very good, awesome, thank you very much. Everything squared, perfect. Because we know also from completing the square that y minus 3 squared is the first term squared minus 2 times the first times the second plus the second term squared. That's why I do this with all my classes from day one. Good, so then this now changes into x squared minus 3 squared. And that's all I needed. I'm coming back to our function because I replaced y by x squared. So I'm coming back to our function, which is negative x and x squared minus 3, everything squared. Bless you. Okay, now we're, bless you. Now we're ready for the x-intercepts. We have the function. I'm going to copy it here one more time. Negative x and x squared minus 3, everything squared. And I want to determine the x-intercepts. One more time, how many solutions will we have to find?
5.
Very good, awesome. So how do I find the x-intercepts for any function? Negative x, x squared minus 3 squared equals 0. Multiply both sides by negative 1. I refuse to work with a negative leading coefficient, and I can always do that in an equation. Why not? So for now, I only have 2 options, sort of. Let's write the option for everyone to see. What is the first option? Very good. How many solutions x equals 0? Multiplicity 1. Perfect. Now I have the other 2 options for now. X squared minus 3 is 0, and x squared minus 3 is 0. They're 2 the same. So let's solve one of them. X squared minus 3 equals 0. How do I solve this equation? What type is it?
You add 3 in square root.
Exactly. Awesome. I couldn't have said it better. Thank you. Why? Because it's the most appropriate situation. It's the most appropriate type of method for this situation. Because I can't factor, really. So I take the square root, but I have to get how many solutions? And I can't forget that. Yes. And they are plus or minus the square root of 3. So then what do we get from here? We have to get 4 solutions. We need 4 solutions. We have 1, and this has to be, from here I have to find 4 solutions. 2 and 2. X equals and x equals. The square root of 3, the negative square root of 3. What is the multiplicity for the square root of 3? Very good. What is the multiplicity for negative the square root of 3? 2. Do I get 5 multiplicities? 2, 2, and 1?
Yeah.
So look at this. All this work was only to find the x-intercepts. All this page. We didn't do anything here.
Wait, is it multiplicity of 2 because technically that's like the square root?
When I solve this, I get 2 solutions. When I solve this, I get the same solutions again.
Oh, okay.
So that's why I have 2 the square root of 3 and 2 negative the square root of 3. 2, 2, 1. Only now I can go back and fill out my chart. I have 0, 0. I have negative the square root of 3, 0. And I have the square root of 3, 0. But I have not established what happens there yet. Can anyone tell us what happens at 1? I'm sorry. What happens at 0 with multiplicity 1? Exactly. Now, what happens at the square root of 3 with multiplicity 2, as well as the negative square root of 3 with multiplicity 2? Very good, awesome. I made my notes. I don't need anything else. The function could be symmetric, however. When I see something happening similar and cross at 0, this time I have to find f of negative x. Let's find f of negative x. Negative x to the fifth plus 6, negative x to the third minus 9 times negative x.
Wait, why did I do that?
For symmetry, odd or even. In the previous situations, when a function crosses at 0 and turns at -2 and crosses at -1, can be symmetric in any way. It cannot be symmetric with respect to the y-axis, and it cannot be symmetric with respect to the origin. So that's why I just write not symmetric. But here, in this table, when I see turns symmetric from the origin, I see a cross at the origin or maybe a turn, I do have to investigate further. Okay, so I plugged in negative x in the function. How much is negative x to the fifth power? Negative, because there are 5 negatives, right?
Yes.
With minus in front, indeed, it's positive x to the fifth. How much is negative x to the third? Yes, with 6 in front is negative x to the third. And negative 9 times negative x is positive 9x. Remember 3 questions. Does this equal f of x? Does this equal negative f of x, or none of the above? So let me show you the function. The function is this, and we got this. No, absolutely not.
Because if it doesn't equal negative f of x, is it even?
If it equals f of x is even. If it equals negative f of x, it's odd. So let's try. If I multiply this by -1, do I get that? If I multiply this by -1, do I get that? And if I multiply this by -1, do I get that? So what type of function is this? Odd, symmetric with respect to the origin. So I'll make myself a note. Don't forget. Why is this so important? Here's why. Because if I find whatever I get in the first quadrant, I just copy it in the third with no calculations whatsoever. Why? Because I know it's symmetric with respect to the origin. Or whatever I have in the second quadrant, I don't need to calculate anything. I just copy it in the fourth over the origin. That's why this is important. Okay, I have all the information in here, and I am going to try to make sense of it. So let's make sense of it first. Ready? It's coming from positive infinity. It will turn a -3, 0. It has to come to a maximum. It straight crosses at 0. It has to come to a minimum because it comes back at the square root of 3, 0 and turns and goes to -infinity. One more time. In positive infinity, it turns at -3, 0. It comes to a maximum. It crosses at the origin, comes to a minimum. It has a turn at the square root of 3, 0, and goes to -infinity.
How do you know what it does with the square root of -3?
Multiplicity 2.
Oh, because of the multiple.
That's why we need to identify multiplicity, so I know what the function is doing there. Okay, ready? I plot the points. 0, 0. So this is 1, 2, 1, 2, and the square root of 3 is roughly 1.7. One more time. From positive infinity, turning at this point. Remember, it's odd. Turning at this point, coming to a maximum because it's crosses straight. From this moment on, I don't care about my nodes. Here's why. Because what I have here, I have to copy here. So it comes to a minimum. It turns and goes to -infinity. I'm just guessing now. Let's say that this maximum is 1, -1, 1. What will this be? Correct. because it's exactly opposite. So this is negative the square root of 3. This is the square root of 3. Y, 0, x. This is our function, f of x. Whatever that was, like 5 pages earlier or so. Oh, right here, my pages are underneath. So this is f of x, negative x to the 5th plus 6x cubed minus 9x. With the graphing calculator, I will determine this local max and I will determine this local min, but not with the graphing calculator. I will just figure it out because the function is symmetric. So let's go to y equals. Yes? Questions? Okay. Y equals. Clear. So we have negative x to the 5th, negative x to the 5th, and plus 6x cubed, and minus 9x. Okay. Let's see what viewing window we want. I will keep maybe the standard. Let's use the standard with zoom. Click on zoom and 6. Let's see what happens. It's coming from positive infinity. It has to turn. It has to cross. It has to come to a turn again. It has to turn at 1.73. The square root of 3. It has to go to negative infinity. This piece has to have a copy here. This height is exactly as this low is. This low, the minimum is on the other side. So let's determine this between the square root of 3 and 0. So with the maximum, second in calc, we determine a maximum which is 4 between negative the square root of 3 and 0. Just give me the maximum. And the maximum is negative 0.77, 4.46. Go back to the chart and put in my table negative 0.77 and the maximum of 4.46. Since I know that the function is odd, I refuse to determine the other one. It would be a waste of time. So if this is negative 0.77 and 4.46, can anyone give us this minimum? Absolutely. It must be. So 0.77, negative 4.46. That's when the symmetry comes into play and it helps us graph. It's nice when a function is symmetric. Okay, can we look at division of polynomials, or you still want to choose another problem like this? Do we want to work on another polynomial, or we still have time to look at division of polynomials, just to refresh your memory? Do we feel a little bit better about polynomials now?
Yeah.
No, not yet?
It's kind of, I feel like once I go on my math lab and go over a few problems.
Okay.
I think my math lab's gonna be
It's going to be what?
difficult because it's so specific.
Yes.
That I like the answers.
Right.
Hopefully it's nothing like this, like the square root.
You mean for the x-intercepts?
Yeah.
Yeah, but it was not x squared equals 9 is not a big. But it took us a while to factor and find the solutions. Yes, I agree. Okay, so then we move on to refresh our memory on division of polynomials. Okay, then 3.3, division of polynomials. Okay, so here's one division that it's not in your book, but I would like to refresh your memory on this. Here it is. Let's suppose I have a polynomial divided by one term, also called monomial. So this is the first example. Okay, so let's say I have 3x to the 4th minus 4x squared minus 3x plus 7 to divide by x squared, let's say. Well, the only chance I have here is to split the fraction into 4 different fractions. Why 4? Because the polynomial at the top has 4 terms. And if you say, well, this is not a real division, I would have to agree. 3x to the 4th over x squared minus 4x squared over x squared minus 3x over x squared plus 7 over x squared. If you say, well, what did you do? It's not a big deal. You can't really divide. And I would have to say, yes, I can't. That's the only thing I can do. And simplify each fraction by itself. I remove 2 from here. I remove 2 from the top. So I have 3x squared. I remove 2x squared from the bottom, 2 from the top, minus 4. I remove 1x from the top and 1 from the bottom. And that's all I can do. Not much. However, this is a useful method for other things later. But what I want to refresh your memory basically on is when we divide 2 polynomials. There are 2 possibilities, 2 options. When we divide 2 polynomials that, regardless of what they are, we can use long division, which I will refresh your memory on in a minute. Now, if the denominator is x minus a number, specifically, I can use the long division, but there is another method that is called synthetic division. Synthetic division. So I'm going to refresh your memory on both. So let me pick a problem, or you can pick a problem if you want. This is in section 3.3. On page 392. I would like to start with 13. Six x cubed plus 13x squared minus 11x and minus 15. Everything divided by 3x squared minus x and minus 3. Here's my first question. Can I use the synthetic division in this problem? Let's look at the denominator. Is the denominator specifically a linear expression with x to the first power, in other words, minus a number? No. So I cannot use a synthetic division. The synthetic division has limited applicability. The long division is applicable in any case, except in this case. Except in this case. In any other case, long division is always applicable. The synthetic division, not in all cases. Perfect. So I cannot use this. I will use the long division. Second question. Are these in descending order? Because if they're not, I have to rearrange them. Yes, they are. Third question. What is the degree of the top? 3. Is there any missing term? And you can say, how do I know? Here's how you know. Is degree 3 there? Is degree 2 there? Is degree 1 there? Is degree 0 there? Not power, degree 0. Yes, so there are no missing terms. So I can start the algorithm. And I'm pretty sure you remember it, and I'll explain it again if you need to. 6x cubed plus 13x squared minus 11x and minus 15. 3x squared minus x minus 3. This is the long division. This is the long division. So I'm asking myself now, 3x squared multiplied by what is 6x cubed? 3x squared times what is 6x cubed? 2x indeed. We must distribute to all terms, determine the result, write below like terms, but before we write, we must change the sign because we subtract. Let me explain why, because I'm sure you're going to ask. So when I have, let's say, 3925 divided by, I don't know, 14, then I will say 2. 2 times 14 is 28, but I have to subtract. I cannot add to 39. So although 2 times 14 is positive 28, I change the sign. For the same reason, I will change the sign here every time I write. So 2x times 3x squared is, but I have to change the sign, whatever the sign is, to the opposite. In a second. So 2x times negative x. You're right. You're way ahead of me. 2x times negative x. Negative 2x squared, but I have to write positive 2x squared. And notice that I wrote it under the like term. 2x times negative 3. But I have to write it under like term, but I have to change the sign because I subtract. So indeed, these two go away. Here I perform the operations I see. And here I perform the operations I see. And then I bring down the next in line. Final question. 3x squared times what? Is 15x squared. At the top, I cannot lie. At the top, it has to be the correct. A sign? Very good. 5 times 3x squared. And we have to write the opposite. 5 times negative x. Yes, it's negative 5x, but I have to write positive 5x. And 5 times negative 3. Yes, it's negative 15, but I have to write 15. Everything goes away. What is the remainder? 0. So what is the final answer? Let's write the final answer. Yes. What if the remainder weren't 0? But let's say I'm going to write 0 over 3x squared minus x minus 3. This is not required. But the remainder, if the remainder were 5, this is what I would have written. Whatever, plus 5 over 3x squared minus x minus 3. But that's not the case. So now, what can I say about since the remainder is 0? What can I say about then 3x squared minus x minus 3 is a of 6x cubed plus 13x squared minus 11x minus 15. A? Thank you very much. Thank you, William. Because the remainder is 0. That's why the denominator is a factor of the numerator. It's the same thing I will say to you. 9 divided by 3 is 3. What is the remainder of this division? 0. Why? Because 3 is a of, exactly. Because 3 is a factor of 9. I know I'm getting into our 6 minutes, so I will not do anything new. I will not present the synthetic division today, but I will do another problem like this. Unless you want something else from polynomials or something else. You tell me what you want. Another one like this? Very good. Awesome. So let's look at
synthetic.
no, I cannot do it at 6. I promise not to do new stuff. I will do it on Tuesday.
Probably just like skip like 10 minutes of class. Like what?
Okay. So let's take a look at number 9. 2x cubed plus 7x squared plus 9x minus 20, everything divided by x plus 3. Descending order, top and bottom. Perfect. Any missing term from the top? What happens if there is? And we will look at a problem like that. What happens if there is a missing term? I have to leave a space for that missing term. But there is no missing term. Degree 3 is there, degree 2 is there, degree 1 is there, degree 0 is there. So let's start. 2x cubed plus 7x squared plus 9x minus 20 and x plus 3. X times what is 2x cubed? Let me remind you that all work for test 1 will be closed on Sunday night, right? Please. Okay. Good. So you said 2x squared. Awesome. Then we have to go back and distribute to both. 2x squared times x. 2x cubed, yes, subtract. 2x squared times 3. I write below like term, but I have to change the sign because I subtract. 7x squared minus 6x squared is? Good. I bring down the next in line, positive 9x. X times what is x squared? At the top, I cannot lie. I have to be honest. Sign. If I don't put a positive or a negative, I can't continue, right? Okay. So x times x. I have to change the sign because I need to subtract. X times 3. I have to subtract. This is 6x. I bring down the next in line. Final question. X times what is 6x? Sign. Careful, we never lie at the top. So 6 times x. Subtract. 6 times 3. Negative 18. In the box, I will have how much? Nope, we perform the up. Yes, Eric, go ahead. You want to say something? Okay. So please, anyone, final answer, please.
2x squared plus x plus 6 plus
Minus, this is the sign is minus,
negative
30, no, not minus minus, but minus at the top 38 and the bottom,
X plus 3.
that's it. What if I say to myself, I don't trust this? What do I do? Yes. How do I do it? I'm going to stop right now. So I multiply this by this, subtract 38, and see if I get that. Thank you for staying.